This is the assignment for video streaming. Let's start with the server code. This is the server class, and we are taking the server port from the command line, which will be run on the server. Then we will create the RT. Then we will create the RTSP socket and with appropriate parameters. Then we will bind the socket here with the server port by this code. Then we will listen to the code. Listen on the server port. Then we will receive client info, which is address and port through RTSP/TCP sessions here, and then we will send this information to server worker class and run it. Here on server worker class, we have 4 types of request, which is setup, play, pause, and tear down. We have different kinds of states, which is init, ready, and playing. There are different types of responses: OK 200, file not found 404, and error 500. Here this is the attribute of the server worker class, client info. We will be assigning the client info to it. Then for each client we will create an individual thread and then pass the function in this thread. This function will receive the request from the client. Now we will process the request accordingly. If the request type, we will get the request type from this, then get the media file name and the RTSP sequence number. Based on the request type, we will process it individually. Process setup request. Here, if it is a setup type request, then we will send the data to the video stream class. Here in the video stream class is accepting the file name. Here this will return the next frame of the file and along with the frame number of itself, and we will get the frame length from the first 5 bytes. If the file is not found, it will the response will be created, which will be file not found 404 with the sequence number 1. Here an RTSP session will be randomly created, and if it is valid, then we will reply will be sent OK 200, and we will get the RTP UDP port number from the last line. If it is a play type request, then we will create a new socket for RTP from here. Then we will give a response of OK 200, and for each request we will create a new thread and start sending RTP package to it. If it is a pause type request, then we will first stop the thread, and then we will give the response of OK 200. If it is a tear down type request, then first we will pause the thread, then here we will pause the thread, then return OK 200 response, and then we will close the socket. Then sending RTP over UDP. This function will send RTP packets over UDP. It will stop sending if the request is pause or tear down. If not, then using video stream class we will create next frame function, and it will return the next frame of the video. Here we will get the address and port number from the client info, and then if it is not valid, then we will print connection error. Make RTP function, it will get the data and frame number and convert it into RTP packets. Here are some flags for the function. Here, with the help of RTP packet class, we will create an RTP packet, and the data frame will be the input for it, and then we will get the RTP packet at return. And this reply RTSP function it will send RTSP reply to the client. If the code is this if code is OK 200, we will print 200 OK. If it is an error message, then we will print 404 not found or print 500 connection error.
Now we will look at the RTP packet file, whose function is to convert the data frame into the RTP packets. First, we have declared an RTP class, which includes the information of the different functions that we are going to add in the RTP packet. This RTP packet class encodes the data or payload that we are sending by adding a 12-byte long header information. As we can see, we have declared a header size of 12. Now, we will look at the different functions which are in the RTP class. First function is encode function. This encode function defines the header of the packet by setting different bits in a 12-byte header array. Now, these are the 12 bytes which we are heading in the header array. Now, second is the decode function. This function, in this function, we are decoding the byte array and returning the data. Now, here is the sequence number. This sequence number will return the current sequence number which the client is running. Now, the next function is a get payload function. This function will return the actual data that we are sending from the server to the client. And lastly, we have a get packet function. This get packet function will return the whole packet, which consists of the header plus the payload which we have created. This was all about RTP packet file. Now we will move to the client side. So first of all, we have a client launcher file. This is the in this file, first we are accepting four types of system arguments, which are the server address and the server port number on which the server is running. This third argument is the RTP port number on which the RTP packet will be running, and the next one is the file path, which is the name of the file which we want to stream. And after this, a client object will be created. Now, in this file, we have added the Tincter library, which is a Python library which is used to make GUI. This Python, when combined with the Tincter library, provides very fast and an easy way to create the GUI applications. After in that we, after doing this, we will run a main loop, which will help to create a client class, which will be running till the end.
In the client side, we have the methods at setup, play, pause, and tear down. The init method initializes or rather sets up the object variables like the file name, RT sequence, session ID, etc. Now in the create widgets, we build the GUI, and we take the four buttons for setup, play, pause, and tear down. We use different methods to do the task on these buttons. For example, setup movie, we use send RTSP request of self.setup, and for exit client, we use self.teardown as the send RTSP request. For pause movie, we give the self.pause command, and for play movie, we give self.play as the send RTSP request. Now in the listen RTP, we receive RTP packets and check if the server frame number is greater than the current frame number. If that is the case, then we discard the late packets, and in the case of self teardown, we shut down the socket and then close it. The write frame function and the update movie function are used in the GUI to capture the frames and then update the movie at the client side. The connect to server connects to the server using the server address and the server port. The exception message is such as connection failed or connection failed due to the specific reason is shown here. Now send RTSP request. Here we use multiple threadings for multiple requests, and we store the previous request sent and through the self.setup. Now in our receive RTSP reply, we we take the while loop for infinite duration, and we pass the reply using encoding the decoding the reply messages. And if there is a self tear down, we shut down the RTP socket. For parsing the RTSP reply, we take the sequence number and session number from the reply message, and then we do the task accordingly, like changing the state. If it is if the setup is done, then we change the state to ready. If the request sent is play, we change the state to play. If the request sent is pause, we change the request to ready. And if the tear down event is occurred, we check the self tear down acknowledge equal to 1. Now for open RTP port, we create an RTP socket at the client side using server address and RTP port, and we bind the socket to RTP port. We have this handler for cancelling the commands like quit or are you sure you want to quit.